I'm going to go through all of the multiple choice questions from the 2.0 Intro to Derivatives packet, but I want to start with this. I pulled these from the those conclusions that we drew at the bottom of the first part of the packet about the relationship between increasing and decreasing in the derivative, or concavity and such. I did add a little bit more detail on here, but this is something that you definitely need to have memorized. And as we go through these questions, I'm going to talk about how I would use this chart to answer questions. Okay, so for example, if I'm looking at a graph of f prime and the question is asking me something about f, then I'm using this right here, where if I can see that f prime is positive, that tells me f is increasing, okay, or vice versa for a negative derivative. Okay, so going back to this, starting with number 1, and I already labeled this one. Also, please make sure that you pay close attention to which graph you are given. So here it says the graph of the derivative of f is given, so I labeled this as f prime. So we want to know which of these 3 statements is true, or must be true, okay? So first of all, the graph of f is increasing on these intervals. Well, according to that chart, in order for f to be increasing, then f prime needs to be positive. So is f prime, the graph we're looking at, positive from -3 to 0 and from 2 to 5? All right, so from -3 to 0 right here, and from 2 to 5, yes, the function is positive on both of those intervals, so this one is true. Number 2, the instantaneous rate of change at x equals 0 is 0. Okay, well, the derivative is the instantaneous rate of change. Instantaneous just means at a moment, but instantaneous rate of change is our derivative, okay, or slope of the tangent line or slope of the function at that point. All of those things mean the same. So is the derivative of f at 0, 0? Yes, it is. Okay, so this one is also true. And then the graph of f is concave up on the interval from 2 to 5. Well, that chart tells me that for f to be concave up, f prime needs to be increasing. And on this interval from 2 to 5, f prime is decreasing, not increasing, so this one is not true. And then my answer is that 1 and 2 are true only. Okay, for number 2, the graph of f prime is shown. So again, we're looking at a derivative. We want to know what must be true about the graph of f at 3. So something about what's happening here, okay? All right, first of all, just looking at these answers, I'm going to go ahead and eliminate that last one. Remember that knowing the slope of something or knowing the derivative of something does not tell us anything about where the function is or where a point is vertically. It could be above the x-axis or below. So also this one doesn't look like it's similar to the others, so let's get rid of that. Okay, so now we need to know, is f increasing or decreasing, and is it concave up or down? Well, in order for the function to be increasing, f prime needs to be positive, which it is because the height here is 2, so f prime of 3 is 2, which is positive, so f is increasing. Okay, meaning we can eliminate these two. And then for the graph of f to be concave up, then f prime needs to be increasing, okay? And for f to be concave down, f prime needs to be decreasing. Well, at this point right here, we are on a decreasing interval of f prime, meaning that f is concave down. So C is correct. For number 3, the graph of f prime is shown. Based on the graph, which of the following statements is true? So again, we're looking at the derivative graph. Okay, so part A, is f discontinuous at x equals 3? Well, in order for a function to, or if a function's derivative exists, then the function is continuous, okay? We can talk more about limits and such there, but this one is false because the function f prime does exist at 3. Now remember, it's not asking about whether f prime is discontinuous here. It says f is discontinuous. Well, because this point exists, then yes, f is continuous. Okay? Moving on, f is increasing on 3 to 7. For f to be increasing, then f prime needs to be positive. And is f prime positive on 3 to 7? No, it is not. 3 is right here. Okay, no, because from 3 to 5 it is negative and then switches to positive, so that one is false. F has a local max at x equals 5. Okay, well again, from that chart, to have a max, we need to change from a positive slope to a negative slope. So, are we changing from a positive derivative to a negative derivative at x equals 5? No, we are not. We're changing from negative f prime to positive f prime. So this one is false, but a negative to positive change on f prime means a negative to positive slope on f, so we do have a minimum. So this one is true. And let's just go ahead and check this last one. F is constant on 0 to 3. F is not constant. A constant graph has a slope of 0, but here, since f prime is equal to -2, then that means that f has a slope of -2 on the interval from 0 to 3. So in other words, it has a slope like this, which is not a constant function. It's linear, but is not constant. Okay, for number 4, the graph of g prime is shown. We want to know which has the largest value. Okay, well remember, we don't know, so this is g prime. We don't know what or where g is, but we do know kind of what its shape is going to be, okay? So for example, we know that at x equals 0, g has a slope of +3, which is pretty steep. So I'm going to draw really just an x-axis here, okay? And so we'll say here's 0, 1, 2, 3. And so I'm sketching a possible g just to get the shape, okay? So at x equals 0, we have a slope of +3, so it's a pretty steep positive slope. Okay, and then the slope is decreasing, then we have a slope of +2, +1, and then down to a slope of 0. So at x equals 1, we have a slope of 0. So it becomes less positive or less steep until we get here, and then we have a slope of 0, okay? And then instead of curving downward and giving us a negative slope on g prime turns around and goes back up to a slope a little bit bigger than 1, okay? So our slope starts becoming positive again. Now, it doesn't get quite as steep, but it does get positive, okay? And then up to about 2.5 or a little less than 2.5. And then the slope, now the function g does not turn, but the slope starts decreasing back down to a slope of 0. So slope is decreasing to a slope of 0 at x equals 3. Okay, and then after x equals 3, the slope becomes negative and then just gets much more negative. So negative and then just kind of drops off. And we don't really know how far that goes. We can assume it kind of continues forever like that, but that's really all we know. All right, so which has the largest value? Because g is increasing from 0 all the way until x equals 3, then this is going to be the highest point. And again, it doesn't matter where this graph is vertically. We do know that the highest point is going to be at x equals 3. So g of 3 has the largest value. Okay, number 6, we are given the graph, and here we do have an equation. So this is the graph of f. 2 cosine x plus cosine of 2x, not something you would have to graph by hand, but they tell us what the equation is, okay? And we're told that our interval is from -1 to 2 pi, so that's useful information here, that this is at x equals 2 pi, and this is -1. Okay, our question is, how many critical values does f have on the open interval from 0 to 2 pi? So thing number 1, critical values means that the derivative is equal to 0 or doesn't exist. So in other words, it means that f prime would be equal to 0 or f prime would not exist. Okay? And then thing number 2, how many critical values does it have on the open interval? This means that we are not including 0 and 2 pi. Okay? So we don't include what is happening here at 0, and we do not include what is happening here at 2 pi. Okay, so if you answered E and said 5, you probably were including those two things, okay, but really the answer should be D, 3, because we would have a slope equal to 0 right here, whoops, don't know what that was, right here, and right here, okay, again, open interval, so we do not include what is definitely a max at x equals 0, and looks like it might be a max at x equals 2 pi. Okay, and then because this is a smooth curve, it doesn't have any jumps or holes or cusps or anything, then there's nowhere where the derivative doesn't exist. Okay, for this one, the graph of f is shown, and we are looking for the graph of f prime. Okay, so f is given, we're looking for f prime. So let's see what the slope of this curve tells us about what f prime will look like. All right, well, starting down here, we have a very steep slope. And remember how we went through and drew those little tangent segments? We can kind of do that again if we want to and see that we have very steep, positive, less positive, less positive, less positive to 0. So the function f prime on this interval should be positive but decreasing, and then at -1, f prime should be 0 because it looks like we have a horizontal tangent there, and then f prime becomes negative because this is a decreasing function f, meaning f prime is negative. Okay, so this decreases down to, and then at x equals 2, f prime is again equal to 0 because we have a min, and then it becomes positive. So f prime should be positive, and then 0, and then negative, and then 0, and then positive again. So that's what we're looking for, okay? So positive, then 0, then negative, then 0, then positive again. Okay, positive hits 0 but does not go into the negative, so this one is out. Okay, positive and then negative, okay? And then positive and then negative. Is that what we wanted? No, we just want positive, 0, negative, 0, positive. So because this one is negative over here, this is out. This one right here is positive, and then it is negative, and then it is positive again. Okay, so it might be that one. Let's keep looking though. This one is upside down, so that one's not going to work. This one also matches, so what we need to do is we need to consider the points, okay? And we said that f prime of -1 was 0, and f prime of 2 is 0, meaning these x-intercepts are what we're looking for, okay? This one does have the right shape, but it's not in the right spot because this should be at -1, and this one should be over here at 2. So this one is dropped down a little bit too low, okay? So C is our answer. Okay, number 8, the graph of f prime is shown on the closed interval from -4 to 4. There is a relative minimum in the graph of f. Okay, so again, this is f prime. We're looking for a min on f when x is equal to what? Okay, well again, referring back to that chart, f has a min when f prime changes from negative to 0 to positive. Okay, negative to 0 to positive. So we want to know where on this graph is f prime changing from negative to 0 to positive. Okay, well, here f prime is negative, and then it is 0, and then it is positive. So our min on f happens at x equals 3. Okay, over here we are negative, and then 0, and then negative again, meaning f would be decreasing, and then horizontal, and then decreasing again. Okay, so that does not give us the min. All right, and then this one is the same graph again, but now we're looking for a relative max. So for a relative max, we want to know where f prime is positive, and then 0, and then negative. Okay, so f would be increasing, and then hit a horizontal tangent, and then decreasing. Okay, and that doesn't happen anywhere because this goes up, but it never comes back down on this interval. So none of the above. Okay, number 10. Let f prime be the graph shown below. Okay, so this is f prime, which could be a graph of f. All right, well, f prime is negative, and then hits 0, and then it is positive, hits 0 again, and negative. So we need something with a negative slope, and then 0 slope, and then positive slope, and then 0 slope, and then another negative slope. So we're looking for something that kind of has that shape, which could be not 2. Could be 1, could be 3. Now what's the difference between these two? Looks like they're the same graph, except this one is shifted down a little bit. Remember, we don't know where f is vertically, we just know its shape, so both of these would work. So our answer is E, 1 and 3. Okay, for 11, we are given the graph of the derivative of f. So again, we're looking at f prime. For what values of x does f have a max? Okay, so f has a max when f prime changes from positive to negative, when the slope changes or the derivative changes from positive to negative. So we want to know where on f prime are we changing from positive to negative values. So here, we're changing from negative to positive. That's not it. Here, we're going from positive to negative. So it's happening right here at 3, at x equals 3. Okay, so again, we're looking at the graph of the derivative of f. So this is f prime. Which of the following statements must be true? Okay, a max at x equals c. To have a max at x equals c, f prime needs to change from positive to negative. Is that happening at x equals c? No, it is not. F prime has a max, because this is the graph of f prime, but f does not, so that one's out. F has a max at d. Well, at d, f prime is changing from positive to 0 to negative. So yes, this one works. And then statement 3, f is decreasing at x equals e. In order for f to be decreasing, f prime has to be negative, okay? Is f prime negative at x equals e? Yes, it is, because it's way down here. So this one is also true, e. Okay, 13, the graph of h prime is shown. Which of the following statements must be true about h at x equals c? Okay, and here's a new word for us. Differentiable is something that we're going to talk about more in 2.1 and 2. But the word differentiable means that the derivative does exist. Okay, and we actually have a theorem that says if a function is differentiable, then it has to be continuous. If that is not familiar to you yet, it's really not that big of a deal. So this problem is not, if you didn't understand it, not a big deal, because we'll get a little bit more into depth with what the relationship between those are, okay? But at x equals c, since this is the graph of h prime, at x equals c, okay, the derivative does exist because there is a point here, okay? The derivative exists, so h must be differentiable. I'm going out of order. Okay, if it's differentiable, it has to be continuous. So if 3 is true, then 1 also has to be true, okay? And then is h increasing? Well, if h were increasing, then h prime would be positive. This value is not positive, so this one is not true. So E, 1 and 3 are true. Okay, 14, f is a continuous function. The graph of the derivative of f is shown. So again, we're looking at the graph of f prime. We want to know where f has a point of inflection, okay? And again, point of inflection is a point where f changes concavity, all right? And that chart tells us, the bottom part of that chart, let's flip back to it for a second. Looking down here now, okay? So it tells us that f has an inflection point, okay? If f has an inflection point, then f double prime will change signs, okay? If f double prime is changing signs, that means that f prime is changing between increasing and decreasing, okay? Because we're switching between this top row and this bottom row, or vice versa. The order does not really matter, okay? So if we're looking at the graph of f prime, we want to know where f prime changes from increasing to decreasing, or vice versa. Okay, and I'm just using a delta for change, a little triangle for change. You're welcome to write the word out if you'd like. All right, so where is f prime changing between increasing and decreasing? Well, looks to me like this is decreasing, 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 okay? It does jump up here, but the curve is still decreasing, right? F prime is still decreasing everywhere. Okay, if this is decreasing everywhere where it exists, it looks like it has an asymptote at x equals 2. But if it's decreasing everywhere that it exists, it's never changing between increasing and decreasing. Therefore, there's no change in concavity, so we have no points of inflection. So our answer is D. Okay, 15. The graph of, again, f prime is shown. We want to use the graph of f prime to approximate the intervals on which the graph of f is concave up. All right, so again, from that chart, if we use the bottom half of that chart, f is concave up when f prime is increasing. Okay, so where is this graph increasing? Well, this graph is increasing here, and then it decreases, and then it increases again. So it is increasing on 0 to 2, and then it decreases from 2 to 4, and then increases again from 4 to 6. So our answer is D. Okay, 16. The graph of the derivative of f is shown for what value of x is f concave down. Okay, so we're looking at f prime. We want to know where f is concave down, meaning we want to know where f prime is decreasing. Okay, so where is this graph decreasing? It is decreasing on this interval. Okay, on this interval. So of these values between 2 and 4, where is which one of those is an option here, and the only one is 3, okay? At x equals 2, this graph is neither increasing or decreasing because we have a max there. It has, so we'd have a horizontal tangent line, okay? And then 5 is outside that interval, so 3 is the only value in that interval. Now that doesn't mean 3 is the only answer, but it means of these choices, 3 is the only one that works. If 4 was an option, well, they wouldn't make 3 and 4 an option because it would be, oh, actually, no, 4 would not be true. Something like 2.5. They wouldn't make 2.5 an option because then we would have 2 correct answers. Okay, 17. The graph of the second derivative of f is shown. So this is now f double prime. Okay, which of the following statements must be true? So we're looking at the concavity of f based on the graph of f double prime. So in order for f to be concave up, f double prime needs to be positive. So we want to know where this graph is positive, since all of these are about concave up. Okay, at x equals b, right here, is this graph positive? Yes, it is. At x equals c, is the graph positive? Yes, it is. At x equals e, is the graph positive? No, it is not. It is below the x-axis. So our answer is D, statement 1 and 2. Okay, number 18, we're looking at the graph of f to determine where f is increasing. So, oh, I'm sorry, where the derivative of f is increasing. Okay, so again, from that chart, are you noticing a pattern here? From the chart, f prime is increasing if and only if f is concave up. Okay, this is part of that chart. F prime is increasing if and only if f is concave up. So we need to look to see on what interval is this graph concave up. Well, concave up, remember, is cup-shaped. Okay, it could hold water. All right, so from, if I'm tracing this concave up part, I can go to about, now somewhere, there's not a real clear inflection point happening, but there is a change between being concave up and concave down. It happens about halfway in between these, but really that's close enough of an estimate. I mean, they're not going to have like, 3.2, 3.3 as 2 different options, but so we're looking for the interval that goes from 0 to 3. Okay? All right, 19, the graph of G prime is shown. We want to know which could be the graph of G. All right, well, let's see what G prime tells us about G. If G prime is negative, then G is decreasing. Okay, so here we would have a negative slope on G, and then we would have a positive slope, and then we would have a negative slope, and then a positive slope again. So we're looking for something that decreases, and then increases, and then decreases, and then increases again. Also, we can use our x-intercepts to determine if we have extrema on G, and since G prime changes from negative to positive, so negative slope to 0 to positive, again, is a min, so we have a min on G at x equals, I don't know, we'll just say negative 0.8. It doesn't really matter. It's just a guess. Something a little bit to the right of -1. Okay, at about negative 0.8, and then again at 1, 2, 3, in between 4 and 5, so about 4.5. Okay, and then we have a max at x is, let's see, just a little bit bigger than 2, so let's say 2.1. Okay, so we're looking for something with 2 minima and 1 max that starts decreasing and then increasing, decreasing, increasing. All right, so this is decreasing and then it is increasing. That one is out. This one starts by increasing. That one is out. This one is decreasing, then increasing, then decreasing. Decreasing, increasing. Nope, we're missing another. It doesn't turn back around, so not this one. Decreasing, increasing, this one looks like it could be a contender here. Let's double check the last one. Decreasing, and then it jumps to increasing and decreasing, and then increase. We got too many turns in this one, so this one's out. Okay, so it looks like D is our answer. Let's double check the extrema. Do we have a min a little bit to the left of, or to the right of -1? Yes, we do. A little bit to the right of 2. We have a max, and then in between 4 and 5, we have another min, so looks good to me. Okay, number 20. The graph of f double prime is shown. Use the graph of f double prime to approximate the intervals on which f is concave up. So we want to know where is f double prime positive for f to be concave up. So this graph is positive from here to here and from here on. So 1 to 3 and then again after 5. So our answer is E.